Hello everyone, my name is Lutfi, and in this video we will continue talking about moderation of temperature by water, and this time we are going to talk about mostly about the water's specific heat, and these are the main subjects for this video. And so without any further ado, let's get started with our video. So the ability of water to stabilize temperature stems from its relatively high specific heat. Okay, and so the specific heat of a substance is defined as the amount of heat that must be absorbed or lost by 1 gram of that substance to change its temperature by 1 degree Celsius. Okay, so it can raise it by 1 degree Celsius, or it can also decrease it by 1 degree Celsius. Okay, and we know water's specific heat from my last video, which I recommend you watching that video. So the specific heat of water equals 1 calories per gram and per degree Celsius. Okay, which it is abbreviated as the equation shown in this picture. Okay, which is written like 1 cal slash or backslash, I don't know, I think it's slash, in parentheses gram dot C, okay, or degrees Celsius. Okay, and we read this by 1 calorie per grams multiplied by degrees of Celsius. Okay, and compared with other substances, water has an unusually high specific heat. For example, ethyl alcohol has a specific heat of 0.6 calories per gram per degree Celsius, okay, or degrees Celsius. And a fun fact is that because water has a specific heat which is relatively higher than some other metals, water will need more heat to change its temperature, while other metals only need a small amount of heat to change their temperature. Okay, so the specific heat is not higher in solids. Okay, so it doesn't depend on the substance that is more solid or more liquid. Okay, so this is a graph of some substances that are very intriguing. Okay, that you can use this graph to find the specific heat of different substances. Okay, so this is the same reason that if you touch the side of an iron pot, your hand will burn, but if you touch the water that is inside that hot pot, okay, it is still warm, and it's not like the burning sensation or feeling of the hot pot. Okay, or in other words, the same amount of heat will raise the temperature of 1 gram of iron much faster, okay, than it will raise the temperature of 1 gram of water. And that's why the cooking pots are made mostly or mainly from specific metals that have a lower specific heat, so that they can pass the heat energy much easier to the food that we are cooking. Okay, so that the heat energy is not lost that easily. Okay, and we don't use much fossil fuels or any heat substance that we use to cook our food. So we can trace water's high specific heat to its hydrogen bonds. Okay, so to break these hydrogen bonds, we need to apply heat. so that the molecules kinetic energy increases, and thus the molecules get more spaced out, and the hydrogen bonds are weakened to the point that they are broken, and the molecules fly off, and this is the point at which water boils. But other liquids or matter that don't have these strong bonds will become very heated very fast, and they will give off the heat very fast as well, which this is in the case of the hot pot. Okay, and so these are the main no and so these are the hydrogen bonds, or the main hydrogen bonds, that are keeping the water molecules together. Okay, so everything is over in this slide, so let's go to the next slide. Okay, so what is the relevance of water's high specific heat to the life on Earth? Okay, so a large body of water can absorb and store a huge amount of heat from the sun in the daytime, and its temperature goes up just a few degrees. And in the nighttime, it gives up off the same heat energy that it had absorbed in daytime to the air in the night. Okay, and this capability of water serves to moderate air temperature in coastal areas. Okay, so the high specific heat of water also tends to stabilize ocean temperatures, creating a favorable environment for marine life. Okay, so a real life example at which I have experienced is that when it is summertime and the sun is scorching hot, and when you come out of the car and with not wearing any shoes, your feet burn very badly on the sand. Okay, and it's just torture when you have to take more than 10 jumping steps mainly to reach the cool water. Okay, and if you think about it, the difference in the temperature is very much. Okay, and thus, because of water's high specific heat, the temperature that covers most of the Earth keeps the temperature fluctuations on land and in water within limits that permit life. Okay, and also because organisms are made primarily of water, they are better able to resist changes in their own body temperature than if they were made of a different liquid that had a specific heat that was very lower. Okay, and that's mainly when we sweat, when we are running or doing an exercise or running for our lives. Okay, and so that was all for this video. I hope you enjoyed it, and in the next video we are going to talk about evaporative cooling, which is another essential part of moderation of temperature by water that we also use in our own body. So stay tuned for that. Okay, and so as always, happy learnings to you all.